Alright, here we are with Unit 8, Section 5, Example 1, that says, prove the two triangles below are similar, then find the length of RT. So when I'm looking at this picture here, I notice that I have two triangles and they're overlapping. So I have angle R that is actually a part of both triangles, and we're going to come back to that information later. So I have triangle RSV and triangle RTU. When I'm looking at these triangles, and I'm trying to think about how can I prove that these are similar, I'm going to go through my checklist. So I have angle, angle, and I have side, 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 and I have side, angle, side. Because I know that the length of RT is missing, I don't have two complete sides. So side, angle, side is not going to work. And I don't have three sides given to me, so side, side, side isn't going to work. That leaves me with angle, angle. When I'm trying to solve using angle, angle, the first thing I recognize is that I have these angles here, angle RSV and angle RTU, that have those markings that allow me to say that they're similar without doing any work. So my first line of my proof is going to say that angle RSV is congruent to angle RTU because it is given. Next, I need to find another angle that is congruent between these triangles. And the only option for that is angle R. So earlier I was mentioning that angle R is in both triangles, so I can do a unique statement for a situation like this where an angle is shared. So I can say that angle R is congruent to itself. In other words, angle R is congruent to angle R by the reflexive property, which allows us to say that something is congruent to itself. Okay, so I have angles RSV is congruent to angles RTU, and I have angle R is congruent to angle R. That is now enough information for me to go ahead and say that I have two congruent triangles. So I'm going to go ahead and write for my third line of my proof, triangle RSV is similar to triangle RTU by the angle, angle, triangle similarity theorem. Now that I've proven that I have two congruent triangles, I can go ahead and find the length of RT. So as I'm trying to find the length of RT, the first thing I notice is that I have, for that smaller triangle, triangle RSV, I have both the base of 8 and I have that side of 10. So I'm going to go ahead and I'm going to set up a ratio of 8 to 10. And I'm going to use that to set up a proportion for my missing RT length. For that big triangle RTU, I have that base side of 12, but I'm missing the side of RT. So I'm going to go ahead and represent that with an X for now, but then at the end I'm going to go ahead and I'm going to plug RT in for X. So first I need to go ahead and solve my proportion. So I have 8 over 10 is equal to 12 over X. I'm going to solve by cross multiplying. That gives me that 120 is equal to 8X. I still need to solve for X. I need to get that by itself, so I'm going to go ahead and I'm going to do the reverse operation of the multiplication that is shown there. So I'm going to divide 8 out on both sides, and that gives me that X is equal to 15. Because X is equal to 15, and I know that X is representing RT, my length of RT is 15.